This is the next video in the chapter on chemical bonding and molecular geometry. We just introduced ionic bonding and how to predict if a particular element is going to be a cation or an anion and what that charge might be. And now we're going to talk about how ions can contain multiple atoms inside of one ion. So what we saw already, all the ions we've talked about so far, they are something called monatomic ions. You might be able to guess what that means. They're atoms that only contain a single atom. And many of the ions that we work with will be like this. So for example, sodium plus was one we talked about, or oxygen 2 minus. Those are monoatomic ions. But there are a few special ions that exist that actually contain multiple atoms functioning as a single ionic unit. So in polyatomic ions, they are charged molecules which behave like a single unit. So even though they have multiple atoms in them, we always carry those atoms together. We always write them together when we write the formula of a molecule, and we give one charge for the entire polyatomic ion. So an example of one we'll talk about is NH4+, which is called ammonium. All 5 of these atoms move together. They're traded and bonded together as one unit. And unfortunately, if this isn't something that you've covered in high school, we have now reached the point where it is time for you to make flashcards and memorize some of these polyatomic ions. Remember that learning chemistry is a bit like learning a language. And in order to speak the language, you have to have some vocabulary before you can start forming sentences and thoughts and ideas in that language. And so polyatomic ions are one part of the language that we need to be able to speak. So I've tried to decrease the list to the smallest I can for what we need right now in this course. I've included ones that are relevant in the laboratory and that we'll talk about a lot during the lecture. So the easiest way to memorize these is to put them into groups by their non-oxygen component. So the first group we're going to talk about is called the nitrates. And in that group is NO3-, which is called nitrate, and NO2-, which is called nitrite. And spelling is going to be important here because they have pretty similar names for significantly different compounds. And these endings are used on purpose. The "ite" ending indicates that there are not less, fewer oxygens in this molecule, and the "ate" ending indicates that there are more oxygens in the molecule. They both have the same charge, but there are fewer oxygens in NO2 and more oxygens in NO3. And you'll see that coming up several times in these polyatomic systems. So next we have the sulfates. SO4 2- is called sulfate. And SO3 2- is called sulfite. And again, we have those same endings. The fewer oxygen is the ite, the more oxygen is the ate. Unfortunately, it isn't a nice straightforward rule where the ite indicates that there's a certain number of oxygens. As you can see, nitrite has 2 oxygens, but sulfite has 3 oxygens. So it's not supremely helpful, but it is slightly helpful. We also have the phosphates. And phosphates all have a PO4 3- unit. So that one's the simplest one, and it's called phosphate. Then we can take this PO4 unit and we can add hydrogens onto it to reduce the charge. So if we add 1 hydrogen, HPO4 has a charge of 2-. So in this case, the charges are actually changing. And so we name this one hydrogen phosphate. Indicate we just added a hydrogen to that base unit. And we can even do it again. H2PO4 with a charge of 1 minus. And so that one is called dihydrogen phosphate. So we indicated how many hydrogens we had, and you can see that all of these have the 8 ending, indicating that there is another version of a phosphate compound that has fewer oxygens in it. And we have the carbonates, the simplest one being CO3 2 minus, which is called carbonate. And the next one, which is similar to the phosphates, adding an H to the front, HCO3 and reducing the charge by 1. That's called hydrogen carbonate. Make sure you can see all the letters. There we are. And you might know this guy by a different name. It's also called bicarbonate, which is in baking soda. But I like hydrogen carbonate better because there aren't actually 2 of anything in this molecule, so I don't particularly like that name. Okay, so we've got the nitrates, the sulfates, the phosphates, and the carbonates. And then there are a couple other important ones that I want to tack on to the end that don't fit nicely into a particular group, but that are still going to be important in conversations that we have in this class. So we'll include some other anions and other cations at the end. So important anions include Cn minus, which is called cyanide. We have OH minus, called hydroxide. We have O2 1 minus. Be careful that the 2 goes in the subscript and not the superscript there. Peroxide. And we also have a slightly larger one, CH3COO minus. That one is called acetate. And we'll talk much more about that when we get to acids and bases. And then the 2 important cations that I like to talk about are NH4 plus ammonium that we listed above. And that one's called ammonium because it's made by protonating NH3, which is called ammonia. And we have H3O plus, which is hydronium. And these are the only 2 cations that are commonly used. I'm sure others exist, but they both end in onium. I guess this part too. So you can use that to help you remember that these have a positive charge. And also note that the hydroxide OH minus and the hydronium H3O plus, that's the protonated and unprotonated version of water. So these 2 kind of go together in their own family. So get out those flashcards and make sure you know what the charges are, what the chemical formulas are, and what the names are, so you can properly speak the chemical language.